Okay, this is part 5 of this May 2024 Unit 4 exam from last summer for the International A-Level Edexcel Physics. So we've been through 4 parts already. I hope you watched them. If you haven't, you'll find them in the same playlist as this. If you want to go and look at those first, don't forget to like, share to help the channel. That would be great. We're now up to nearly 700 subscribers. We started this channel this year, and the aim is to get to above 1,000 before you finish the academic year. So question 16 is about the Large Hadron Collider at CERN. So it says scientists at CERN are planning to an upgrade to the Large Hadron Collider called the Large Hadron Electron Collider. Okay, now, I don't know if this is true or not. It's just a scenario for you to read about to be able to explain how they would use a linear accelerator. Okay, so the scientists plan to use a linear accelerator, or LINAC, to produce high-energy electrons, and then collisions between these electrons and high-energy protons will allow the structure of protons to be investigated. Now, obviously, the internal structure of protons is the quark structure, and this kind of probing of protons is called deep inelastic scattering, and it was in fact a continuation of using small particles to probe matter more deeply after Rutherford did the Rutherford alpha scattering experiments to determine that most of the atom was empty space. They then realized that all the mass and was concentrated in a very small nucleus. We're talking about the size approximately 10 to the minus order of 10 to the minus 15 meters. Okay, so called femtometers. So this is really what this area of physics is looking into. Okay, so to read the question then, the high energy electrons produced will have energy of gigaelectron volts, which is 10 to the 9. Yeah, I mistakenly wrote 10 to the 12, which is why I've scribbled out my answer. So this should read 10 to the 9. Yeah, gigaelectron volt is 10 to the 9. And then you use that value, yeah, to work out the speed of the electrons, okay? So you've got to show that if you use this Newtonian mechanics, show that these electrons will be traveling at relativistic speeds. Now, relativistic speeds means that speed around the speed of light, or that's what they mean by relativistic speeds. Now, remember that when particles or anything travels at relativistic speeds, Newtonian mechanics breaks down. So Newtonian mechanics only can be used up to a certain speed, and beyond that you have the Einsteinian effects, which is to do with E equals mc squared. And that's what they are showing you, that if you convert this gigaelectron volts, yeah, into joules, you'll get a certain number of joules, because remember, every time you want to change electron volts into joules, you multiply by the charge, yeah, E equals QV, yeah, and you always multiply by the charge of an electron, 1.6 times 10 to the minus 19. That's what an electron volt means. It means charge times voltage, okay? So here's the voltage, and here's the charge, and that gives you the energy in joules. Now, if you had that much energy in joules, which we've equated here, and it all goes into the kinetic energy of the particles, which is half m v squared. If we do that, then the half m v squared we know will be equal to that. We know the mass of an electron from the data sheet, so you can look up the mass of the electron, and that allows you to determine that v squared will be this equation here. So you can simplify it to that equation there, and you will get an answer to two significant figures of 1.5 times 10 to the 11 meters per second. Of course, that is like 1,000 times almost, or approximately nearly 1,000 times, 500 times the speed of light. Yeah, so it's greater than the speed of light, which is of course impossible according to relativity. So that shows that Newtonian mechanics breaks down at relativistic speeds, but you then have to answer the questions. It says at the beginning of the question, it wants you to show that these electrons will be traveling at relativistic speeds. Well, it's even going faster than the maximum speed possible. So you have to say they must be considered, to be traveling at relativistic speeds. Okay, they certainly will be going very fast, but the maths goes wrong because the mass of the electron, m, will increase when v increases. So mass is not constant, So the mass in relativity increases with velocity. And there is an equation for that if you want to look it up, okay? So that's how you do the first part of this question. So it wants you to understand how a linear accelerator works. And the next part of the question goes into that. Well, here, is the diagram for a linear accelerator. And it says the diagram shows the start section of a linear accelerator. Well, the start section is on the left-hand side, where I've drawn the arrow. And the end section is that the electrons keep going through what are called drift tubes, Now you'll notice that these drift tubes keep getting longer and longer from the start to the finish. So this is the continuation here of the drift tubes as it gets longer and longer. So like, imagine that the linear accelerator is just getting longer and longer, and inside it these drift tubes are getting longer and longer. Now between the drift tubes you'll notice that there is an AC supply connected to the drift tubes, each consecutive drift tube. So if the first one is positive, then the second one will be negative, and then the third one will be positive again, by the, I haven't done that right. The third one will then be positive again. So let's go back to the pen. So this one will then be positive again. That's meant to be positive. Okay. So this one will also be positive, and then this one will be negative, and so on. And this keeps flipping because it's an AC supply. An AC supply means that it's alternating voltages. So, and it has a fixed frequency. The frequency of the AC supply will flip at a fixed amount of time, the period. And they've had to, so obviously the time between the drift tubes is constant in terms of the voltage changing from positive to negative. Now, if you want to accelerate the electrons, so when your electrons are going in, the electrons come from the left. You can see the electron source is at the beginning. When the electrons, you want the one in front of the electron to always be positive. Then when they're in the drift tube, they're at the fixed potential, so they don't accelerate in the drift tubes. But when they come out again, if they hadn't flipped, so the second drift tube that we're looking at now, this one, if this one is not positive, when the electron comes out of the first drift tube, it will repel the electrons and it will slow it down. So they time it, they synchronize it, so when the electron comes out of the first tube, the second one will then become positive as the electron exits the first one. And the first one will then become negative, and then the third one will be negative, and the fourth one will be positive. So they keep flipping, so as soon as the electron comes out of the drift tube it's in, the drift tube in front of it will be positive, and each time it will get electric field accelerating it, yes? So remember, the electric field force is F equals the charge of the electron in this case times the electric field strength, which is the voltage divided by the distance between the drift tubes. So that's the electric field strength between the drift tubes. So the acceleration happens between the drift tubes. So each time it's between the drift tubes, you get a force on the electron, okay? And that force on the electron can be calculated. So they want you, in this question, to explain what I've just explained to you. Explain how a linear accelerator, produces high energy electrons. Obviously they go in with zero velocity, and then they gradually get faster as they come through the different tubes. So obviously in your answer you should refer to the AC supply like I did, and to the reason why the length of the drift tubes needs to increase as the electrons go faster, because obviously if the time spent in each drift tube will be the period of the AC frequency. So the time in each drift tube will be constant, so you need to make the length such that as the velocity goes up, the length needs to increase. So this is a 6-mark question. Any question with an asterisk is a 6-mark question where they want you to have depth, detail, and clarity in your reasoning, okay? Now, I've explained it to you orally, and I don't know if you stopped the video or you can go back and listen to me speak, but I would start by saying that there is an AC frequency and it has a fixed period. And then I will explain that why that means that you need to increase the length of the drift tubes as the velocity increases. Okay, so let's have a look at the mark scheme. So what I did was I put the mark scheme at this section. Here you can see part A, which we already did. And how we work out the velocity. So that's the first part. And then part B, it explains how you get the marks. And it says the question assesses the student's ability to show a coherent and logically structured answer with the linkages and fully sustained reasoning. So I explained my reasoning orally. Marks are awarded for indicative content, yes. So the indicative content is here. So when you do your, when you're writing it, you need to include the things at the bottom. And for how the answer is structured, showing lines of reasoning. So if you haven't explained it in a clear way, you may only get 4 out of 6 marks or whatever. And the table shows that they're looking for, first of all, they're looking for the content, and then they will give you up to 4 marks for your content. And then for your reasoning, they can give you 2 marks to be able to give you the final mark of 6, okay? So that's how they mark these questions. All right. So for example, your reasoning, to get the 2 full marks for the reasoning, this descriptor is used, okay? So this descriptor is used here, shows a coherent and logical structure with linkages, and a fully sustained line of reasoning is demonstrated throughout the student's answer. So what are they looking for in terms of content? So in terms of content, they're looking for these points. So the first thing, here we're looking for the content. So the first thing you should say is the first point. Perhaps the electrons are accelerated by an electric field between the drift tubes, which I did explain to you, okay? So that's a good way of starting. The AC polarity changes, so the electric field is always in the same direction when the particle is in the gaps, so we don't care that when it's in the tubes that that is still not able to, it doesn't have an effect when it's in the tubes itself. So we want it to synchronize with the electron leaving each drift tube, and when it comes out, we want the electric field to be in the direction, yeah, is such that it will be positive, yeah, as the electron leaves each drift tube, okay? Or you could say the AC polarity changes so that it's always accelerating the particles when the electron leaves the drift tube. Now you also need to make the point, which is key, that the AC frequency is obviously constant. Yeah, like the mains electricity in most homes is at 50 hertz. Yeah, so the AC supply will have a fixed frequency, and the length, therefore, of the drift tubes increases. Yeah, the length of the drift tubes increases, so the electrons spend the same time in each tube, and therefore that's the important bit. So as soon as they come out, the polarity has flipped, yes, and it will always be positive when it's in front of the electrons. And then it says the tubes have constant length at the end. Yeah, the tubes have constant length at the end. So as the electrons approach, the speed of of light so no longer increases. I'm not sure the bit about this tubes have constant length at the end, why they're putting that. Okay, let's have a look at the diagram. And then as the electrons approach, so the first four parts are the content you need, and then your reasoning will get you the extra marks. So the tubes at the end they're saying that the tubes at the end have constant length at the end of the linear accelerator. So let's have a look at the diagram. It's not something I was looking at. So they mean the second part of the diagram at the end section. They're talking about this section here. Yeah, so you're right. They're right. They are not increasing at the end. Okay? So you need to also include the end section. So what's going to happen here is that they do not increase in length. So that means the length is constant. That means the velocity must have reached a maximum value. Okay? So they can't speed up anymore. Therefore, if they can't speed up anymore, there is no reason to increase the length anymore. And that's the point that I did not explain to you in my run-through. It's a good thing that I looked at the mark scheme to see that the end section they've put with equal length drift tubes, and they're saying that's because the velocity has reached its maximum value. Therefore, they need to make the length corresponding to that maximum velocity value. Okay? So that's something that I would have missed, and I wouldn't have got this full marks. So you can see how easy it is to not pay attention to the detail in the exam questions. Okay, so the end section that they are talking about is this section here, and you need to make sure that you pay particular attention to that when you're answering the exam question. And really, a really good way of revising is by scrutinizing the mark schemes if you have access to them. Most of the old ones you have access to. This is a 2024 paper, so I think it's still locked, but I know there are websites that students tell me they can find all of the mark schemes. So going back to the mark scheme, that last 2 points will get you the last 2 marks of the exam. So these points in red, yeah, these points in red at the bottom, the tubes have constant length at the end as the electrons approach the speed of light, so they know that they've approached the speed of light, so they no longer speed up. So the length does not need to increase. Okay, so that's an important distinction between this exam question and previous exam questions on linear accelerators. So the first 4 marks, yeah, or the first 4 contents, yeah, points are to do with a normal acceleration that occurs and how the drift tubes are directly proportional to the velocity of the electrons as they exit. And then at the end, if they reached the maximum speed, they no longer can increase, so the drift tubes do not need to increase correspondingly. Okay, so that's the 6-mark question, a really good revision question for you to make sure you take detailed notes on, and that's, you've got to put your verbalization in that section. So always check the mark scheme if you have the ability to do so. Finally, the last part of the question, it says, explain why high energies are required to investigate the structure of protons. So this is really useful for people also doing Edexcel linear A-levels, because it's to do with the de Broglie wavelength. Okay, now the de Broglie wavelength, it has an equation on your formula sheet which shows that the wavelength is of electrons is equal to Planck's constant over its momentum. Okay, so if they have high velocities, high energies, they will also have larger momentum, and larger momentum, which is P on the bottom of that equation, means that the wavelength is inversely proportional to the momentum. So the wavelength will become small, yeah, and it will be approximately the same size as a proton or smaller to be able to probe it, yes? So if it can't be, if the wavelength isn't small enough, it basically will not be able to penetrate it because it will bounce back. It will just not be able to get through the gaps. So if you think of the wavelength as the size of the probing instrumentation, then it must be very small. It must be roughly the size of the proton to be able to probe it. And that's the same with any wave. If you have a wave, for example, diffraction, the wave and the obstacle must be, in this case the proton, must be roughly of the same order of magnitude. Okay, and smaller wavelength leads to better resolution, yes, generally speaking with wave theory, and it leads to more detailed observations being possible. This is a more general answer to do with why small wavelengths lead to better resolution, and therefore it also will allow, in this case, the penetration of the proton, which is, we're talking about 10 to the minus 15 meters, yeah? So I don't know what exactly the speed of the electrons would be because we were using Newtonian mechanics, but you could put this wavelength, for example, if the wavelength is approximately equal to 10 to the minus 15 meters, you can put it in this equation and see what kind of momentum you need to be able to get that wavelength which would allow you to probe a proton. Okay, so this is a very important part of why they do particle physics, is to probe the structure of matter, to be able to get an understanding of what everything is made of and how it's all comes together in the first place. Right, well, this is the end of this long run-through of question 16, which has become the style of my later videos. So if you found it useful, make sure you like it, give me a boost, and share it with your friends so we get more subscribers. And if you haven't subscribed, make sure you've done so, and you will see the next video going up. Probably not today because it's now Christmas Day. Okay, well, thanks for watching. Hopefully see you in the next video. Bye for now.